There are four phases of matter that are very common: solids, liquids, gases, and plasmas. We're going to take a look at three of them: solids, liquids, and gases. Plasmas are a unique state where you have an atom who's given a lot of energy and it shoots the electron out of orbit. So now we have what we call an ion. We have a positive ion and a negative electron floating around together in the same gaseous state, and that is a plasma. Whereas a gas, you're not going to have those free electrons shooting around. That's really the difference between a gas and a plasma. Plasma is the most abundant state of matter in the universe because all of the stars are in a plasma state. Neon bar signs, those are plasmas. But we're going to concentrate our discussions on solids, liquids, and gases. So we're going to look at solids first. Solids have a definite shape and a volume. You can see from the picture that there's bonds between all of the atoms in a solid. They can't go wherever they want to, so there's a definite shape and a definite volume. So a rock, for instance, right, it stays the shape, it stays the volume, unless you apply some sort of external force that deforms the shape. They have a rigid 3D structure. They're held in place, and their vibrations move very quickly through them because all the atoms are touching each other. So when one atom starts shaking and the next atom starts shaking, it's going to move down the line very quickly. But they stay in place. They don't move around the atoms in a solid. There are two types of solids: crystalline solids and amorphous solids. Crystalline solids have an arrangement, or the atoms are arranged in a pattern. So if you break the crystalline solid, it keeps the pattern always. Whichever piece you're looking at, you know it's from that same element. Whereas an amorphous solid, when you break an amorphous solid, there's more of a randomness to the structure of the atoms. So you don't get a clean break. Both sides of the atom don't look the same if you looked at them under a very high-powered microscope. So they both have different properties as well, but these are the two types of solids. We're going to look at a few characteristics of a solid. First one is density. Density is how compact the molecules are. So something that is more dense, the molecules are closer together for a given mass. We can see over here high density versus a low density. If those same types of atoms, you can see in the cube that is lower, the molecules are closer together, so you can pack more in there. So the mass of that cube is much greater than the mass of the cube where the molecules have more space. So the compactedness, how tightly arranged the atoms are, that's your density. The classic, what weighs more, 100 pounds of feathers or 100 pounds of bricks? They both have the same weight. The difference is that the bricks are more compact, they're more dense. You can have 20 bricks, stack them on a desk, and that would weigh about 100 pounds. Whereas you'd have to fill a whole room full of feathers to get 100 pounds of feathers. The formula for density is mass divided by volume. If we use it in symbols, rho is the symbol for density. It's like a fancy P, it's a Greek letter. Rho equals m over v. So volume is 3 dimensions, length times width times height for a rectangle or a cube, and it would be 4/3 pi r cubed for a sphere. Tension is another property with solids. Tension is resistance to being pulled apart. So a rope, when you apply tension forces to it, a rope is very strong. The thickness of the rope is going to resist the tension. So the cross-sectional area of the rope is going to decrease the amount of tension that the rope feels. By increasing the cross-sectional area, you have more atoms in there, and those atoms, remember, they're bound together, so they can form more of a link that allows them to resist the rope being pulled apart. The thinner the rope, the less atoms there are holding it together, the more tension it's going to feel. So to decrease the amount of tension felt in an object, whether it's a rope, a chain, a wire, the thicker it is, the bigger cross-section it has, the less tension or the less stress that's going to occur in it. Compression is a force that pushes them together. Some objects are very strong under compression, some are very weak under compression. Something like concrete has a high resistance to compression, a very low resistance to tension. So when you're putting a concrete wall up, you reinforce it with rebar because you don't want it swaying, and that tension from the wall swaying would create a lot of stress inside that concrete and it would probably crack. So you put the rebar in there to resist that tension. Compression is the molecules being pushed together. And you can see here a golf ball being compressed. It can be compressed a lot. If you've ever seen a slow motion swing like we did in Momentum, the golf ball can get compressed. And normally it springs back out. But under this machine, with the constant compression, it just continues to smash the atoms and they have nowhere to go except to buckle the ball. Elasticity is the ability to be stretched and return to your original shape. That's the key with elasticity, to be able to return to your original shape. If you can get stretched and then you break, you're not very elastic. Things like a rubber band we associate with elasticity, a golf club shaft, a golf club face, a golf ball. These are all elastic items. They get under a lot of stress, and then once that's gone, they return to their original shape. Here you can see someone working out with bands. And if you ever worked out with bands, you know they have different amounts of elasticity. You may start your workouts when you're just beginning with a pink or a red band, and you work out with that band until it gets too easy, and then you move on to the blue band, and then you move on to the black band, and then to the purple band, because as you gain strength, it's easier for you to pull that elastic material apart. You also know with elasticity, the more it stretches, the more difficult it gets to stretch.